Hey, YouTubers, Tazman here, bringing you another episode of T4zzTeaches Programming Logic. And so, in our last episode, we kind of got into some deep stuff with two's complement and stuff. You don't have to understand that 100%. I just wanted you to understand that there actually is. A way that it stores the negative numbers, because we did talk about that an integer is a positive and negative number, but we didn't actually go into any other thing about a negative. Hold on just one sec. Okay, sorry about that. So in this episode, we're actually going to be getting into I keep saying actually a lot. We're going to learn more about structure of programs, and with the information you have by the end of this lesson, hopefully you'll be able to kind of draft out your own kind of program in what we call pseudocode. So speaking of pseudocode, that's the first thing we're going to be learning about today. Is we need to click on you. There we go. And go PSUD pseudocode. And what pseudocode is it's not quite English sentences, but it's also not a programming language. It's kind of in between. So with pseudocode, we kind of use pseudocode logic all the time. Like we say, okay, well, if it's raining outside, I'm going to wear a raincoat, right? If it's sunny outside, I'm going to wear shorts. And in pseudocode, when we're doing it, we can do it two ways. We can say if, and we're just going to abbreviate a lot of this. So if it is, we're not going to say it is, but let's say if RAIN, if rain, then, can't write, then raincoat. COAT. Other words, or we're going to say else, normal. Okay, so this is, in programming, this is called a decision. And decisions always have either a true value or a false value, which kind of makes sense since, when you get all the way down to the bits, it's either positive, negative, true, false, on, off, so on and so forth. So this is going to return a Boolean value. So if, and we're just going to put this in parentheses because this is what we call our condition. So if rain, then raincoat. So we might have somewhere else in our program something that checks the weather, right? And then finally we come into this part of the program and we say, well, if rain, so this other part of the program tells us that yes, it is raining, right? Then we do raincoat. So if, or actually I did this wrong, this doesn't go here. It's just saying if rain, which is true, then we put on a raincoat. Other words, we dress normally, right? If this is false, we dress normally. So this is in programming logic and in pseudocode. This is the pseudocode right here. The computer doesn't understand it, but it's written in a format that we could turn to code fairly easily. And if we were drawing flowcharting, because sometimes it's really a lot better than have sentences explaining what you're doing, is actually have a flowchart of your progress. And in the flowchart world, this is done as a diamond, and then we say our condition in the middle. And it has two outputs. It has the yes or true. Actually, let's say true because that's more computer speak than not. Go up a little higher. A little higher. There we go. So we could say if it's true, then we follow this branch. If it's false, we follow this branch. So this branch right here would say it's true, we wear a raincoat. If it's false, we dress normally. So this is a condition, right? This is our conditional statement or our conditional drawing here. So let's go ahead and talk about our next one. So we're going to hide that one. So our next one is a loop. So sometimes, if you read on a shampoo bottle, for example, it says wash, rinse, and repeat, right? So in programming, we actually have something called a loop. And there's 3 types of loops, but we're going to talk about the basic structure right here. A loop is generally written, trying to remember the flowcharty thing. Hold on just a sec. I think I have on my desktop somewhere a picture of kind of the programming logic stuff. So give me just 1 second. Okay, so a loop, I don't know why I was drawing a blank. A loop actually uses the same, it's a conditional thing, so it's checking for something. But a loop, for example, is, let's see, so we would wash our hands. Wash hands. And then we have our condition saying if still dirty. And this is kind of like the if statement, but it's contained in a loop. So we would say if dirty, start over. Other words, or else, we continue, dry them or whatever. Dry or rinse, wash hands. So a loop kind of looks and acts, like an if statement in programming, just because it has that condition. So that's why these are conditional checkers. So in a loop, for example, we would say something. Let's use a new little symbol here. We're going to say get soap. Right? So we're going to get soap and wash hands, right? So here's our little check here. And we're going to say if dirty. So this goes here. And if it's true, if it's still dirty, then we repeat these steps right here. So what it's going to do is if they're dirty, then we come back and we do it again until it's not dirty. If it's false, in this case, if it's not dirty, then we can dry hands. Okay, so this is kind of a real rough idea of a loop. Now there's actually 3 different types of loops, and there's actually there's 3 types of if statements. So our first loop is called a while loop, right? And so we have while. The next one is called a do loop. And the final one that we have is called the for loop. And all of these things have their advantages and disadvantages. So let's just go ahead and we're going to clear off this screen and start a new one. And we'll just talk a little bit. So our while loop, what it does is it checks the condition at the very beginning. So for example, because we were outside playing, we need to wash our hands, or we just went to the bathroom, we need to wash our hands. We don't need to check our hands before we wash our hands. We know they're dirty because we just went to the bathroom, right? We need to wash our hands. So a while loop will have the condition at the very beginning. And actually, I'm telling that backwards. We do check our hands. So a while loop would be like if we're outside and we're playing, maybe we didn't play in mud, maybe our hands aren't dirty, so we kind of look at them, right? So we do our condition first. So we check condition first. Then our do loop is the opposite of that. So a do loop you're doing something, but you're actually going to do the condition, or you're going to do the process, and then you're going to check if it was successful, right? So a do loop, how do I want to say this? Let's say do process at least once, and then check condition. And then check condition. And then finally, our for loop. A for loop is actually a counter. We use this a lot for counting. So we will say, do this 10 times, and then it runs 10 times. While this, you're going to do it until the condition's met. So on the while loop, I'm going to look at my hands. They're dirty. I'm going to wash them. If I look at them, they're still dirty. They're greasy from working on the car or something. I'm going to rewash them. And I'm going to do that until I look at my hands and I say, okay, my hands are clean. With the do loop, I'm going to go to the bathroom or whatever. I'm going to wash my hands. Then I'm going to look at them and say, yeah, they look clean. Or I'm going to say, no, they don't look very clean. Hopefully they look clean after going to the bathroom. But it's something like if I was playing in mud, or I was making dough or something like that, where I know my hands are dirty, I don't need to look at them first. I wash them, then I go look and say, okay, did I miss anywhere? And so on and so forth. Where the for loop, you're saying, no matter what, I'm washing my hands 5 times. So you get them, you wash 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 them. So you do it 5 times, right? Now, since we've got room here, we're going to talk about our if statement. So we have our if statement, which we went over, which is just a simple condition that we do something if it's true, right? So an if statement, we do SOME, oh, that's an ugly M, METHING, if condition's true. If COND equals true. Then we have our if else statement, which means, so we have if, we'll do a dash there, and or maybe a slash else. And this is the same as that, where we do something if the condition's true, but if it's false, we do something else. So we do something else if it's false. Then we have what's called our what's it called? Else if, I can't think. Then we have one that is, let's say, we'll say it's the if slash else if, LSE, else if. And then we have the option of having an else at the end. And this does what this says. However, instead, FALSE, false. Instead, what this does is we check in conditions. So, for example, this might be with school grades. And I don't know how to really word this one, but if we have school grades, we'd say if an A, right? So if the student has an A, give them $10, right? Else if a B, give the student, let's use an arrow instead of equals. Let's give a student, let's give him $5, right? And then we could say else if again, and you can do repeated else ifs, or you could just say else, saying that, other words, they'll get nothing. E-L-S-E, else. And this means any other condition. If these two are false, it fires off this one and give them 0. Give them nothing, right? So this is an if-else, an if, else if, and of course you can have the else in there, but you don't have to have the else in there if you don't want. You could just have the two. So these are our decision things. And like I said, these always look like this. Now, if you want to know what this might look like as far as this goes, you know, like if A, give $10, let's just kind of draw that out just so we kind of get an idea of what that looks like. So here we go. Is that the one? Let me just check real quick. That's nothing. That's something. Okay. So if we wanted to draw our oh, whoops, I have to unhide that layer. If we wanted to draw, say, our little statement of the else if and the if, the else if and the else, what we would do is we would say if the student, let's see, if A, right, if it's true, we give $10. Let's just say $10, burp, like that. If it's false, then we do another condition, right? And we say else, if it's a B, or if it's a B, we give the student, if it's a B, we give the student $5. Other words, or else, I did an E instead of a false. Other words, they get 0. So as you can see here, it will do this. You know, it'll execute and it'll check this one. If this is true, then they give $10 and it doesn't do anything else down here. We don't have a link going down here. So if they're an A, there's no reason to check if they're a B, right? If they're a B, there's no reason to execute this. So this would be the end of the program. If we drew this, we might have this kind of go like this, and then these all come together, and maybe down here we have our end. Up here we had our start, like that. So as you can see, we have our logic, and this helps us sometimes drawing out your idea of how you want the program flow to work helps you decide the ultimate way this program is going to look, and helps you design how your code is going to look. Whereas if we said something like this, it could get a lot harder. In fact, let me just pull up over here. I'm going to show you a program in pseudocode real quick. And this area right here, usually you use kind of an oval or circle for the beginning of a process. You use kind of a, what is this, a trapezoid, where it's slightly angled like that when you're inputting or outputting information. So in this program right here, this right here just represents our storage in memory. So we're creating an integer. So we're creating an integer named num1, we're creating an integer named num2, and we're creating a temp integer named temp, right? We're creating 3 integers, and there's their names. So what we're doing is our program's starting, we're getting the first number. So if this number, for example, is 5, and I can't actually write it down because this isn't a place I can write, I don't think. Actually, no, I can't. Then it would store in num1, and sorry about the case. A lot of programming languages are very, very, very picky. So if this were a lowercase num and this were an uppercase num, this would actually have a syntax error. It needs to match exactly. And I kind of screwed up all over the place on this one. I have num1, num2 right there, and temps right, but okay. Anyway, so what's going to happen in this program is it's going to get num1, it's going to assign it to there. It's going to get num2, and it's going to assign it to there. So if we have, for example, a 10 and a 5, then it's going to say, is number 1 greater than number 2? And if number 1 is greater than number 2, then it's going to output to the user num1 is greater than num2. Other words, what we need to do, if num1 was, say, say 3 and num2 was 10, then what we would have to do is do a quick little swap to make it so this output will be true. So what we do is we take the temp variable and we assign it num1 and we put that there. So now the 10 goes into num1 or into temp. Then we take num1 and we assign it num2, so that gets the 3. Or actually, I'm doing this backwards. This gets the 3, that gets the 10 now. And then finally we take num2 and we assign it the integer that's stored in temp, which is 3. And therefore this would output correctly saying that num1 is larger than num2, right? So this is what it looks like in pseudocode. And then our program ends. Really quick, I just want to show you just some various programming languages, including the pseudocode. So right here in my Notepad++, you can see this is pseudocode. So we have the start of the program. We ask the user for the first number. We commit the first number to memory. We ask the user for the second number. We commit the second number to memory. Then we compare the two numbers, num1 with num2, to see if num1's bigger. And we say if number 1 is larger than the second number, so if the first number is larger than the second number, we need to swap those. So here we don't actually have that little code that says, okay, we assign the temp variable, blah, 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 because we do this in our head all the time. Then we go ahead and tell the user what the larger number is and what the smaller number is. So if we look in early, just in BASIC, this is how you write the same thing in BASIC. And we're not going to get really into what all the code is. We're just showing you how it's all quite similar. So to write that exact same program in BASIC, I wonder if I could actually, let's try something real quick. Let's move this over here, just so we can kind of have that up in the background. Oh, I think I closed it. Darn it. That's okay. We'll just continue on, forging forward. So in BASIC, what we would do is it's called dimming instead of initializing. It's called dimensioning a temp variable as an integer. We can also dim 2 at once and say dim num1, num2 as integer. Then we get the user's input. We say what is num1, what is num2. We check it, we do our little thing. We can do the same thing in C#, where we're setting integers as num1, num2, and temp. Then we're writing out to the user saying enter your first number. We commit it to the memory, or we put it in our variable. Then we do the same thing with the second number. We put it in the thing. Then we simply check. Now here you'll see we have just a standard if. It's just saying if num1 is greater than num2, then we do the swap. Other words, we're always going to output to the user the results. So we don't need an else statement here. If we were going to do some other type of swapping and then output the results, then we could have the else. Here we have it in C++. You'll notice a lot of same stuff, except for here's how you send information out to the user. Here's how you get information into the computer. But you'll notice the if statement is kind of the same. You know, it's even here. It might not have the brackets and stuff, but it's kind of following the same logic. Now here we go with Java. And as you can see, we're initializing our integers. We're checking what the user, or we're setting up our scanner or our input. Then we're outputting to the user the question, we're taking their input, we're doing it with the second one, and then we're doing the same thing. Even in Perl, which is a Linux kind of language, we do the exact same thing. We output to the user, we assign what they say to our variables, and we do our if swap if necessary. And then I also added in early BASIC, which was called spaghetti code, because you had things that took you other places. You know, you'd have these go to 130, which would move you back up here. So in this case, as you can see, we're saying, and this is, thank goodness they don't do this anymore, but it used to be that you would assign line numbers for every single line. It would automatically assign it a line number. And or did you? No, you typed in the line number. So here we're getting the input for A and B. Then we're checking, And if A is greater than B, we skip all the way down to here and we do our lines of code. And then we go all the way back up here and we output. If this is false, if A is less than B, then it just goes ahead and does this and tells you what the smaller number is, and it ends the program. So this was ugly code back in the day, but it was what we used, so we had to use it. All right, so that kind of gives you an idea of those structures, and we kind of even talked about a little bit about some of the other things where your beginning of a process is generally a circle, and usually it has start. Oh, I'm trying to write with my mouse, which is terrible. It would say start in here. Now I've got my pen again. So S-T-A-R-T. And then the end, of course, would have end in it, and it looks the same, E-N-D. And you can change these, to what makes more sense to you. Then we have our conditions, which is the diamond with our condition inside. And this was like our if statement, our if, and our looping statement. We also talked about our processes when we're actually doing something. Usually it's just a block like this, and this is doing a process. And then our inputs and outputs are usually, is this called rhombus? We'll just do I/O, which is what, oh, not 0, O, control. We have IO for input and output, and I think that was it. So the one thing I wanted to talk about, so we did talk a little bit about the if statements here. There's also where you could have some really ugly code going on with this if else then, because it's this giant nest. There is one more that we'll talk about it later, but it's kind of like a simplified way of writing a if else, else if, and else type statement, and it's actually called a switch. It's actually called other things in other languages, but I think the majority languages call it a switch. And it's where it has a single condition that it checks, and then it has just lots of cases that it checks the condition against. So we'll probably talk more in depth about switches a little later on. Yeah, because I don't think we have much time. And a switch is written exactly the same way that you do the if, else if, and else statement. But instead it's called switch for the if, and then the else if would be a case, and then the else would be called default. So that's if everything else is false. It goes ahead and ends or outputs the default. So I think this gives you quite a bit to chew on. Maybe we're only at 28. Usually these take a bit longer because they're harder to set up. Let's just go into Java real quick and just play a little bit with some of these. So let's say we have here, let's see, I'm going to pull out my keyboard. We're going to go ahead and create a quick little package here, and we'll call this structure. We'll call that structure, and inside here we're going to have our actual Java class, and we're just going to call this prog structure. structure. Okay, and then we got that. So we need to have a starting point. So that little circle at the very top was our starting point. And in programming, even though we have this in Java, we have classes and stuff, we still need the starting point. We need to tell the computer where this program starts. If we tried running this right now, it would end up telling us it can't because there is no, oops, actually that's the wrong one. Let's just do it here. We'll do run as and run configurations. Actually, no. We have to save it real quick. let's just add our code. If we tried running this right now, it would basically error out because there's no entry point. There's no start point. So we need to create the start point. And I think in our last episode, we kind of talked a little bit about the entry point. And in this, we call it public, P-U-B-L-I-C, public, S-T-A-T-I-C, static, and, oh, it's not uppercase. That's why that's erroring. Like I said, Java is a very, very, very picky one. P-U-B. So there we go. Public static void main. M-A main. And we need to do string. And like I said, I think we talked just a little bit about this the last time. ARG. And then we have our brackets. So this is called the body. This is from bracket to bracket is the body. And everything, when this is launched, everything in this bracket, set of brackets is considered our code. If statements in Java use the same thing to signify this is the if statement. This is the code or the block of code for our if statement. So let's try first. Let's just do int. And let's set my num equals 0, for example. So there's our integer, and its name is my nim. Gosh, I can't write. So my num. And let's just check. Actually, let's set this to 5. So let's set it to 5, just so we can have a little fun here. And let's just do an if statement now. So we say if, and then we have our condition. So we would say if my num is less than, and let's just give it a static number, and I didn't do my uppercase. This is why it's great to have an IDE. It actually highlights things for you. So there's my num is less than, let's say 2, because we know this is false, right? So if my num is less than 2, then we're going to output to the user saying false, right? So we're going to say system.out.print println, system.out.println, and we're going to say, so if it's true, this is kind of weird to think. So if my num is less than 2, then that would be true, right? We know that's not, but that's okay. Oh, P-R-I-N-T. We have a T instead of an R. So there's our print line. And then ELSE. So we have an else statement because we want to tell the user if it's false. So we have a special chunk of code that's going to be simply if it's false. And we do Control C and Control V, and this will be false. So we know, just by looking at this, we know that it's going to be false, right? So let's go ahead and say F here. In fact, let's set up another variable. Let's call it your num, like so. And this is actually highlighting because it says it doesn't have a resolvable variable. So we need to make it so that it's initialized and say your num, and let's say equals 2. Okay, so this is going to say is my num less than. So let's go ahead and run this. And that's, oh, we need to save it first. And as you can see, it says false because my num is not less than your num. So now if we simply change this and say this is 10, right, and rerun it, we will, and save it and run it. Now we got true because this is a true statement. My num, which is 5, is less than your num, which is 10. So now let's say, for example, we want to, let's, how about if we, so that's kind of our if statement. Now we could also do else if and say else if my num is between two other numbers, or my num is less than 100 or less than 2 or something like that. We could set up this to go, you know, else if, or actually this would be else if here, right? Else if, but then we need a condition that it's going to check, and then we would output that. In this case, it doesn't make sense to have the else if, so we're not going to actually have that. So let's also just take a quick look at a loop. So if we wanted a loop, let's say to say hello your num times, right? We could say while, we're going to need to, we'll do this. We're going to say while, and let's do that, and our condition here is going to be while my num is less than your num, okay? So we're going to say while my num is less than your num. Whoops, wrong thing. Your num. Then we're going to do something. We're going to output the value of my num. So we're just going to grab this guy right here, do a C, do a V right here. Now we didn't, this one, yeah, we do have a close on our while. Wait, no we don't. I think we need to do this. I didn't hit enter there, did I? Because this is the end of our public there, and this is the end of the class. So here we have another thing that's going to say while my num is less than your num. Now if we run this, we're going to have some ugliness happen. As you can see, it's just saying true, 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 true forever. And the reason is because we're not changing anything. My num is always going to be less than your num because we're not changing it, right? So what we need to do in a while loop, generally you have to have an incrementer, or you have to increment my num. Now there's a couple ways we could do this. Let's just output my num. My num. And if we run this, you'll see it'll just 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. Forever and ever, that will just say 5, 5, 5 if we don't stop it. So we're going to stop it. So what we need to do is then we need to do an incrementing of our my nums. So we could say my num, right, equals my num plus 1. So this is, now I've mentioned before, programmers are generally lazy. So what this is going to do is this is going to check the condition, my num is less than your num. And it's going to output my num. Then it's going to take the value of my num, which is 5, and it's going to add 1, and it's going to reassign it. It's going to overwrite this 5, not the actual code 5 that we wrote, but it's going to overwrite in memory that 5 with a number 6. And so now this will go 6, 7, 8, 9, and 10. So let's just double check. Ready and go. There we go. So we have, oh, whoops, our num is 5. So we're outputting our num once first, which is why we don't have 10. Because if we incremented before, we'd actually have 6, 7, 8, 9, 10. So we're outputting 5, which is my num, and then we're incrementing it. So now my num gets 6. Let's just take a quick look at this. So we can actually do something in here called set a breakpoint. And then if we run this in debug mode, hopefully this works. Where is debug? Oh, there's debug. It looks like the little bug. Oh, hold on. I have to go put some info in. I'll be right back. Okay, so sorry. So as you can see here, it ran the code and now it's stopped at our breakpoint. So all I did was click in the side here, and now we have our breakpoint, and it stopped the code. So you can see it did this part. It outputted true. And let's go ahead. Do you want to open the perspective now? Let's go ahead and do that and see what it does. Okay, it's going to show us a lot more junk. So this is showing us a lot of the information. As you can see, this is the arg string right up here that we set for string, and it has no value. Here's my num. This is actually showing you what's in memory. So this is my num, and it's set to 5. This is your num, and it's set to 10. So if we want to kind of just loop through this, let's see, where is the step into word wrap? Nope, nope. I gotta find the right, oh, here it is up here. So step into, this is going to go to the next line. It's gonna check this, and it's gonna go to our line right there. And you'll see now we're there. So now it's outputting to the user 5. And then it's gonna take my num, which is 5, and it's going to assign it +1. So we're gonna see this guy change to a 6. And there it goes. As you can see, we've now done that, and we're going to do our evaluation again. If we mouse over this, we can see my num is now 6. This is still 10 because we don't change that, and we're going to loop through. And now you can see my num is 7, as you can see up here, and this is there. So it's going to keep doing this. Now, if we wanted to continue running the rest of the program, we just click resume, and it would run the whole sequence to the next one. So now you can see my num is 8, 9, and 10, but once it's 10, we're no longer less than. This is why we don't see my num outputting 10, because this is now true, or this is now false. So it's going to say, wait, I'm done, and it's not going to do this. So we're never going to output the 10. So if we go here and do step into, you'll see it jumps to the end of that code. This is the end of the program, because that's the end of this guy, as you can see right here. It highlights that. That means we're out of the main, so that's the end of our program, and it ends. So if we jump into again, program's over, we're done. All right, let's see. So let's go back to Java here, and we can get rid of that. So that is your loop. So now let's say, for example, we want to check if a player wants to play again, right? So let's go ahead, and we're just going to simulate this is a game that you play and it ends. So we're actually going to say up here, we're going to say do, and then we're going to have our bracket, and then down here we're going to have our while. This is where we check our condition after we have done it at least once. So we're going to call this, let's see, if play again. P-L-A-Y-A-G-A-I-N. Okay, so we're going to say play again. So this is going to be a variable. Of course, we need to set up a Boolean called play again. We need to P-L-A-Y, I need an uppercase A. There we go. And we're actually going to assign this a value because we need to have it have a value. We're going to say maybe do while play again is true. So we're going to say true. And we're going to go ahead and do that. So what this is going to do is this is going to start a loop. It doesn't even know what the loop's all about, but whatever it's going to do, it's planning on looping until whatever the while condition is met. Now, because we're doing a Boolean, this is going to be true. So it means it's just going to keep running. We're not doing an actual condition. Holy cow, we're actually running long now. So what we're going to say is we're going to play again until we say no. So let's just go ahead and we're going to say, let's see. So this should be, let's also get us another, let's just do a count. So do int count equals, let's do 1. Now generally we wouldn't necessarily need this, but we're going to want this just to keep track of our play again. So what we're going to do is when this runs, we're going to ask the user if we want to play again, or we're going to, let's just call it do our game stuff. So do Control V. We're going to go ahead and say I'm thinking ahead, do game stuff. So this would be our code that plays a game. And then at the very end, when we die, it's going to say, do we want to play again, right? Kind of thing like that. And it doesn't make sense if I load a program, the very first thing that pops up is, do you want to play again? Because I haven't played yet. Obviously, I want to play at least once because I ran the program to see if I could play. I wanted to play it, right? So here we have, we're going to do our game stuff. Then we're going to have our counter here. So we're going to say count, although I said cout, count. And remember how up here we did my_num equals my_num plus 1? A really quick way of doing just an incrementing of 1 is to do count plus plus or my_num plus plus. And that says simply the same thing as saying count equals count plus 1. And did I misspell that again? C-O-U-N-T, C-O-U-N-T. Why you? Value count is not used. Yes, it is. I don't think it's saved yet in memory. So then what we're going to do here is we're just going to do this loop maybe 10 times. We're going to see it say do game stuff 10 times. And we're going to, because we're not checking if count is a certain number, we're going to have an if statement in here, right? We're going to say if count equals, and remember, I think we talked about it, use double equals because we're not assigning it. Actually, let's just say less than 10. Then we're going to go ahead and do this. We don't need an else statement, but then we're going to say play again equals false. So what this is going to do, this is going to loop 10 times saying play again. And then when this count hits number 10, it's going to say no, and it's not going to play again. Let's just do one other thing. We'll simulate you die. C, Control V, and say, oh no, you died. Dun, dun, dun. Okay, so what we're going to see here is we're going to say do game stuff. Oh no, you died. Do game stuff. Oh no, you died. Of course, that'll be after all this other stuff. So let's go ahead and run it. And you'll see, oh wait, I think I messed something up. Oh yes, because count is less than, right off the bat, count is less than 10, right? So we do want to do equals equals. Let's do equals equals. So when count equals 10. Or we could say when count is greater than 10. All right, save it, run it. And now you see, here we go. We got 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because on number 10, it's not going to loop again. So we're not going to see it again. So there you go. That kind of, hopefully that helps you understand a little bit about the loops, the while loop and the do loop. We could do another example, but boy, we're almost at an hour. We're at 50 minutes almost. We're at 48 minutes. So I really think this is a good place to end it. Hopefully you guys enjoyed it. Hopefully you learned something. Play with this stuff. Maybe in the next episode we'll learn how to get Eclipse because it's really easy to set up. But maybe we'll get Eclipse and explain how to do that so you can actually play with it. And you can try this different code and try different things. You know, the worst that can happen right now with what you're doing is you'll get a syntax error and you just have to fix it. Not a big deal. So like I said, thank you so much for watching, guys. I really do hope you're enjoying this series. If you are, be sure to leave a thumbs up down below. It helps me tremendously on YouTube. And with this being my channel that actually is kind of the neglected child, isn't have as much stuff on it, a lot less subs, those help a ton. So check out my other channels, check out my Discord, comment, like, and subscribe. Follow me on Twitter. I said that in a different order than I usually do, but that's okay. And until next time, I'll be seeing you later. Bye.